New technologies in engineering to reduce water pollution. Since the Industrial Revolution, anthropogenic activities have created new forms of water pollution, and it became increasingly problematic up until the 1960s when the first environmental movements began, and laws such as the Clean Water Act and Clean Air Act were passed in 1970 as people started to realize the impact anthropogenic activities had on the environment. Pollution from factories and raw sewage have been dumped directly into streams as major point sources of aquatic pollution, which led to diseases such as cholera and typhoid. Today, over 1 billion people worldwide lack access to safe water. In 2007, CNN reported that up to 500 million tons of heavy metals, solvents, and toxic sludge slip into the global water supply every year. In the developing world, according to UNESCO, as much as 70% of industrial waste is dumped untreated into rivers and lakes. This is a major problem and is having powerful negative impact on both the environment and the anthropogenic need to access clean, potable water sources. The Exxon Valdez oil spill happened in Prince William Sound, Alaska, on March 24, 1989, and was considered the worst oil spill in U.S. history, spilling over 11 million gallons of crude oil into the ocean. The oil slick covered 1,300 miles of coastline and killed hundreds of thousands of seabirds, otters, seals, and whales. The spill had a total economic impact of around $2.8 billion. Many of the strategies used to combat and clean up the spill were not the most effective and consisted of dispersants, which are chemicals used to break down oil, booms and skimmers to try and contain the oil, absorbents and vacuum cleaners, burning the oil, and biodegradation, in which microorganisms digest the oil. They also used hot water to pressure wash the rocks and shoreline, which appeared to be extremely effective at removing the oil, but often ended up causing more environmental damage to organisms on the coast and would sometimes simply move the oil around rather than clean it. Blue-green algae and red tide blooms. According to the EPA, harmful algal blooms are on the rise, and it is believed to be due to rising global temperatures caused by climate change, which promote the growth of harmful algae and is catalyzed by anthropogenic activities from agriculture, runoff from urban areas, and faulty waste management practices. The higher concentrations of nutrients, specifically nitrogen and phosphorus, mixed with warm water promotes the unbridled growth of algae, typically blue-green algae, known as cyanobacteria. As the algae overwhelms the water source, marine organisms start to die off and decay in large numbers, which promote the growth of more decomposer bacteria. The bacteria eventually use up all the dissolved oxygen in water, creating a dead zone. This process is known as eutrophication. In the case of red tide, the algae, Carenia brevis, secretes neurotoxins that also have a strong adverse effect on wildlife, and the airborne toxins from the bloom can cause lung problems in humans and other animals nearby that breathe them in. Humans that eat shellfish have been affected by the neurotoxins, can get neurotoxic shellfish poisoning. The neurotoxin is a brevetoxin that affects the central nervous system of vertebrates and causes them to die. For a long time, there were very limited technologies to try and manage algal blooms, like aeration and barriers to keep the nutrients and runoff from entering the waterways. Current technology developed to reduce the impact of oil spills. After major oil spill disasters such as Exxon Valdez and the more recent Deepwater Horizon spill, engineers have been working on new solutions to contain oil spills. A new solution has been recently developed by engineers at A-Star Institute of Bioengineering and Nanotechnology in Singapore to remove oil from marine systems. They're using nanoscience to turn oil into a jelly that can be more easily removed than oil in its natural state. Chemist Yugen Zhang at IBM has developed several molecules that can turn crude oil into jelly, known as supergelators, which are designed to associate with each other without forming physical bonds. When sprayed on contaminated seawater, the molecules immediately bundle into long fibers between 40 and 800 nanometers wide, which create a web that traps the oil in a giant gel blob that floats on the water's surface. The jelly is then easily removed from the water and is reclaimed by fractional distillation. The supergelator molecules were produced organically with inexpensive, non-toxic materials, which make them an easy solution for managing spills farther from shore. So far, the solution appears to be an effective and cheap solution that has a minimal negative environmental impact when removing the spill and seems to be one of the most effective current solutions for managing oil spills, especially in comparison to the technologies from Exxon Valdez. Current technology developed to reduce the impact of harmful algal blooms. Global engineering firm AECOM and bioplastics firm Bloom have teamed up to create a new technological solution, a semi-permanent system to help contain and harvest the harmful algae from the surface of Lake Okeechobee. It works by removing the rich element of algae cells from the phototrophic zone, a nearly 1-foot layer below the lake's surface. As water is pulled out from the phototrophic zone, it is then transferred to a containment system that has microbubbles on the bottom. From there, a polymer is added to it, which will bind up to the algae cells. This will create a lift to allow these now formed particles to float up to the top to be harvested and removed. It is then placed in a biomass storage unit, and the remaining water is filtered and returned to the lake. The algae, once it is extracted, is taken by Bloom, a company that turns algae into biofoam products such as shoes and surfboard mats. This system has been proven highly effective, and between a few months to a few years, it can return a lake back to its previous healthier state and restore the nutrients it has lost. Not only is it effective in removing algae from lakes, but also helps to reduce the use of petrochemicals and foam products by creating biofoam products from the algae. The potential of a technology in the future. Overall, the new technologies developed today have evolved greatly from those used many years prior and can surely be predicted to be expanded even further. These developments have become extremely advanced in only a rather short amount of time and have been proven to be significantly more effective at both combating oil spills, red tide, and other algal blooms nationwide. In the case of oil spills, many of the old technologies like vacuums and using hot water to wash the oil off the shore were proven to be extremely ineffective and have a more harmful than helpful impact on the environment and were extremely costly. Today, however, with the development of supergelators to gelify oil slicks to easily be cleaned up, has so far appeared to be an extremely effective and far less costly method than previous methods, as the molecules were organically developed and were very inexpensive. They are a very plausible solution to cleaning oil spills in the future. In the case of algal blooms and red tide management, there have always been limitations in managing them as they are so highly unpredictable, and the previous ways to manage them were not overly effective and were only temporary fixes to an ongoing problem. With the development of the removal system from ACOM and Bloom's project in Okeechobee, it has proven to be a more permanent and effective solution to remove algae from polluted waterways, and has even found a way to repurpose the algae collected and create biofoam products from them, which can help reduce the use of petrochemicals. As these technologies develop even further and evolve, there is a high possibility of there being even more effective and inexpensive solutions created to combat these environmental issues. The technologies we have currently already seem to be highly advanced and develop quickly, which seem to show a trend in the development of better solutions for water engineering and providing access to clean water in the future.